Turbo! Hey guys, and welcome to our official Turbo YouTube tutorials channel. Today we'll be going over the game Pancake Cat and breaking down the code so you can have a better understanding of how you can make games fast in Turbo. This is a really good place to start off since it's such a simple game, but we actually have a lot of moving pieces here with some valuable intel so we can adapt that to our games going forward. Let's start off by opening up Turbo, and if you haven't installed it yet, we do have a video tutorial to get you started. We're going to do Tubo Init Pancake Cat, and what this is going to do is it's going to create a project in our directory by the name of Pancake Cat. Initializing a project is how you'll start off any new Turbo game, and if you ever forget the command, we have the syntax on our website at turbo.computer in the command line interface section. So just to show you that while my game's initializing, we can do the press start here, command line interface, and we have a lot of the Turbo commands right here. So init run, that can help you out in case you ever get stuck. With it initialized, we now need to run it. So let's do turbo run -w pancake cat. You see the project run, and then we're going to go head over to where the librs file gets created, which is over in users, Pancake Cat, in a folder called src, and then the librs file should be there. So Pancake Cat is right here. So in the Pancake Cat folder, we have src and then librs. So if I open up librs right here, this is the code of our game right now. One cool thing, so if I change this text right here to subscribe, like, and comment, and then I save the file, we'll notice over here that it changed in our Turbo client. So that's pretty cool. This feature is going to be really useful in all stages of development since it will let us know if our code is working or not. Now that we have our client running and our game running and our Pancake Cat project initialized, let's jump into talking a little bit about the structure. Any Turbo game or project is going to need a Turbo config. Turbo config is configuring the project. It's going to allow you to kind of give your project a description. It's also going to set like the resolution of the screen. So if we go over into our Pancake Cat written tutorial, this Turbo config right here, I'm going to copy it, and I'm going to head into our code here, and above the Turbo go loop, I'm going to paste it. This Turbo config, it's going to give a name to our project, a version, an author, and a description, and then the resolution. If I save it here, we'll notice that nothing really changes in our in our window here, and that's because we didn't really change anything. What we need to do now, we have a Turbo config, and now we need a Turbo Init or a Turbo Initialize. If we hop back into Pancake Cat written tutorials over here, we can take the Turbo Init. I'll copy that, I'll hop back over into my code, and I will paste this Turbo Init right below my Turbo config and right above my Turbo go loop, the structure of any Turbo project where we will need a config, and then we'll need an init, and then we'll need a go loop. With these three in our project here, we have basically the building blocks for a game all sorted out, and we've set ourselves up for success. So I'm going to save that. Now I'll kind of get into some of this code here. This top portion of code contains a struct, or a structure, called GameState. That GameState structure is going to have several variables in it. Those variables, like frame for example, are defined by a value. So we are telling the frame value that it can be a U32. If you don't understand Rust language very well, that's totally fine, because all U32 means is that it is a positive number. If you see F32, that means it's a number with a decimal point. And if you saw I32, that means it can be a positive or negative number. And I believe we'll be using all three of those in this code, so you'll get to see their uses. Right below the game state struct here, we have the actual value. So we're saying that frame is going to init at 0. The variable last munch at is going to init at 0, and then we have the cat x, the cat y, and the cat r, and we are going to give them very specific values. So cat x is 128, cat y is 112, and cat r is 8. And then you might be wondering why pancakes look different up here, and that's because pancakes is a struct much like GameState, and all a struct does is kind of organize and keep data in a location. So basically we're saying that pancakes is holding an x, a y, velocity, and radius value. The score also initialized to 0. We're going to mess with the go loop now. So if we hop back into here and we go back down to game loop, if I paste in the new go loop that I got, what this go loop is doing, it is saying that our game state up here, where we're loading that in, and we're saying that it is changeable, so all the values inside of game state will be changeable, and then we're calling it state. So we're giving it kind of like a new name here. We're going to refer to it as state. So we're going to say let state equal game state, and then we're going to load all those in, and then mute just means mutable, or to think of it even easier, it just means changeable. We are going to save this, and we're going to take a look at our Turbo project, and now the text has disappeared, and if I pull up my terminal here, I can see if there is like an error. So let's error it out just so we can see what an error would look like. So score is a U32 value, which again is just a positive number. So if I change this to 0 with a decimal point, it shouldn't be able to read that. So if I save that, now my code has errored out. It is saying right here that it can't really read that in U32, so if I get rid of this, save it, my code is no longer errored out, it's loading everything. So that's awesome, but we don't have anything in the code. All we've done so far is really just structure our project, and that in itself is really important. Let's add some user input, and let's add a sprite. So let's start off with the sprite, so our user input doesn't do nothing. So let's go over into where the project itself exists, and we're going to add a folder in here called Sprites. So Sprites is a folder now in our Pancake Cat folder, and I'm going to add some sprites into it. If you don't have sprites, over here in Pancake Cat, we have the sprites folder up here, and you can actually grab the sprites. So for this tutorial, you're only going to need heart and munchcat, and heart is kind of interchangeable, so you could use fish or seashell or taco if you want. But for the sake of this, I'm just going to use heart, showing you how to download it. If you click into it and you just click the little download raw file right here, that should download it for you. Now I already have it downloaded, so I'm not going to download it again. Instead, what I'm going to do is open up my downloads. I'm going to take these two files, I'm going to copy them, I'm going to come over into Sprites, and I'm going to paste them. So now I have Munchcat and I have Heart. This is cool because Turbo will automatically read from the Sprites folder. It doesn't need like a file path, and it's going to look there automatically whenever you are making a game if you throw a sprite in there. We've added the sprites into the sprite folder, so now let's draw the Pancake Cat sprite. So if I go down here, we're kind of skipping a lot of code, but that's okay. I want to show you guys actual things that are changing in the game. So at the bottom of our go loop, I'm going to paste in this bit of code right here, the sprite munchcat code, and I'm also going to grab the input code while I'm just over here, because these codes are going to go kind of hand in hand of working together, because one of them is going to draw a sprite and one of them is going to manipulate the sprite. So in the very beginning of the go loop, I will add in input code. Let's start to break down this code, but before I do that, let's save it. And boom, we've got our cat. We can move him left and right. So making sure our code works is a really cool feature. You can see if what you put in works, and if it doesn't work, then you can see in the terminal if it errored out, and you can kind of troubleshoot it from there, and that really helps out. Let's talk about this movement code right here, and then we'll talk about the drawing of the sprites. This right here is basically saying if we input left on the gamepad, it is going to change the cat's X value by -2. And then down here, it looks like if we press right, it's going to add 2. The cool thing about this code is this is a little specific to Turbo, where it can understand what the gamepad is. And what I mean by that is left is already mapped out for you. So Turbo recognizes left as being the left arrow key on your keyboard, and it also recognizes left as being the left on a controller. It's like the D-pad. Turbo can automatically do that, so you don't have to wrestle with like mapping out a controller. So what we're saying for code right here is that the state, or right here, state is mutable, so we are changing the value of the cat X, and we are minusing 2 from it or adding 2 from it, depending on which key we press. And the cat's X value is where he's sitting at in this canvas, and since we add or subtract 2 from it, it moves. And the reason why it moves is because of this sprite drawing code down here. So what we are saying down here is we are drawing in a sprite. That sprite is called Munch Cat, which, if we go over into our sprites folder, that is what the file is named, so that is really important. If I told it to draw heart here, okay, it worked. So now we can move a heart around instead of Munch Cat, but heart isn't an animated sprite, so it's not quite the same. But you know, we kind of got like an Undertale lookalike now as we play as a little heart. But let's go over here to Munch Cat, save that. He comes back, boom. All right, and then what we're doing is we are giving it an X value, and then we are giving it a Y value, and then we're giving it an FPS. And FPS is just like gamepad in the sense where Turbo kind of does the heavy lifting for you. It's going to animate it at a certain FPS value, and there is a few different FPS values which you can find on our website. But let's look at the X and Y positioning and why we use state cat and some math here rather than just giving it like the X or Y position as like a static number. The X position right here, X equals state the cat's X and state the cat's R, we're subtracting 128 from 8, and then we're reading that as an I32 value. And the reason why we're reading it as an I32 value is because these values are F32s, because if that value were to ever go negative, it would an error and break the code. Why we do 128 minus 8 is 120, so ultimately why we do this instead of 120, and I'll just show you here because it's a little bit easier to show. If I change this to 120 and I save it, nothing is errored out, so it works, but he no longer moves because we've set a static value rather than giving it a value that can update through math, because here we're changing the state of the X plus or minus 2, and here we're defining the position by using that value to define it. So it's really important that we use that to determine the position, and just so it's aware, these values 128, 112, 8, these are pixels. Let's add some pancakes to Pancake Cat. We can take a look at this pancake generation code. So we'll copy this code, and there's two things we need to do. Just like cat, we're going to generate some pancakes, so like spawn some pancakes in, but then we also need to draw the pancakes so the pancakes actually appear. Right here, this is a rand function, which I'll go into that if you're not familiar with what that does. Before I jump into that, I'm just going to grab the next portion of code, pancake drawing code. So code, and now right below the cat, I'm going to draw the pancakes. So I'll put the pancake code there, and right before I go into this rands code, I am going to talk about this in case you are unaware of what this is. So the double slashes in a code, they allow you to make a comment. So this would be important if you're ever trying to keep structure or trying to keep organization or trying to convey to like other team members that might be working on something with you, or just like to remind yourself if you write a very confusing piece of code and you're like, I don't know what this does, but it works, and this is what it's doing when it works. So, you know, you can't really look at this and just read it as if it was a book. You kind of have to break it down a little bit, but you can read this as if it's a book. Right here, this code I've just interjected for rand, it creates a new pancake with random attributes. So this is telling us what this code does without me really breaking it down, which is useful. If anyone were to go along with the written tutorial, they could see at least what this code is doing, even if they didn't understand. Because I've added in the pancake drawing code, it can actually draw the pancakes. These two codes kind of work hand in hand. One spawns them and one draws them. Basically what rand does is rand is going to find a random number. So that random number could be 5 million, it could be 64. Ultimately, what we are saying is if we take 64, and this % means divide, so if we take 64 and we divide it by this random number, if that equals 0, so I'll give you an example. If we take 64 and we divide it by 128, we would get 0. We can't fit 128 into 64, so it returns as a 0. That's going to tell rand that something, because we want it to equal 0. We're saying when it equals 0, this is going to happen. So it boils down to a 1 in 64th chance of a pancake spawning. The reason why we do 64 here is if Turbo updates 60 times in 1 second, we're essentially going to get a pancake to spawn every second. So all that might be a lot. Let's kind of like learn by changing this value. So we take 64 here and let's change it to just 6. And let's save that. And you can see the pancakes start appearing. There's so many more pancakes. So we've told it now, instead of, hey, we have a 1 in 64th chance to spawn a pancake, we now have a 1 in 6th chance to spawn a pancake. So we're spawning a lot more pancakes that way. So I'm going to change it back to 64. But hopefully that kind of conveys what rand is doing here. The inside of rand is saying that we have the pancake here, and the pancake's calling upon our pancake structure, and it is getting an x value, a y value, a velocity, and a radius. And there's some math as to why we are doing that. Then down here, we're drawing circles based off of this pancake's random math. The x value is a random number that will divide 256, and 256 is the width of our canvas. So that's why we choose 256 as the value for the x. Our y value is one top left corner. Remember, if I set the cat to 0, 0, he actually goes to where these pancakes are. So our y value doesn't need to change, it's just 0. And then the velocity, we are again doing a random number, and we never want it to be 0. With 0, the pancake would have a velocity of 0. So we want it to be always at least 1. And then the radius, these are just different sizes for the pancake. There's really no special sauce here. Little pancakes and big pancakes. Now that we've broken down the kind of pancake code, we can go down here and do a brief look at the drawing of the pancake code here. So for the pancakes here, we're just drawing 3 different colored circles and kind of giving all of those circles different sizes, but we're all saying that they're going to be kind of at the same position. So that is drawing the pancakes in. It's not a sprite. We're using the circle draw function in Turbo to do that. Now we've got pancakes, and we've got spawning pancakes, and we have a cat, and the cat can move. So now we need them to fall, and when we need them to fall, we need them to be able to be caught by the cat, or we need them to like disappear, because now we just have infinite pancakes spawning, and that could cause a problem to the performance of our game. Let's jump back into here, and let's grab probably the biggest portion of code in Pancake Cat, like the true mechanics behind Pancake Cat, which is the updating pancake position and checking for collision with the cat code. We're going to do that right underneath this rand function. I'm going to add it in, paste it in, and then again, I like to show this stuff before explaining it, just so you can have something to watch here. So I'm going to save it. And all of our pancakes fell. Cool. So all the pancakes suddenly got some physics and they fell. Let's kind of jump into this code here and let's figure out what's going on with it. This first line of code, we are defining the cat's center. So the cat has a value which it's going to be called cat center, and it's going to be equal to the state of the cat's x. So basically wherever the cat moves, his x value will be that, and it will be added to the cat's radius, and then also it's going to be the cat's y added to the cat's radius. So that will be the cat center. That's how we're defining the cat center. It's that x and radius value added on to the y and radius value. So those two things equal our cat center position in Turbo, or in Pancake Cat, I should say. Then we have this little fun line of code here, which it's saying that pancakes is a retain mutable, which again, mutable means changeable, so we know that from earlier. But what is a retain function, you might be wondering? Well, the best way I can describe a retain function is we're deciding which pancakes to keep in the game, and we're deciding which pancakes to remove from the game. So there's a lot of different pancakes, as you can see in Pancake Cat, and when I catch one, like so, it's going to remove that one from the game, but it doesn't remove all the pancakes, it just removes that one pancake. So the retain mutable function here allows me to essentially remove certain pancakes from the game and keep other pancakes in the game. So that's important. You can think of, like in other games, you can think of like bullets or projectiles. When you shoot your bullet, it might hit someone. You don't want that bullet to stay in the game. Or let's say you shoot like 30 bullets and they hit someone because your gun's rapid fire. You don't want all 30 of those bullets to stay in the game forever, because you got other people shooting guns, and then eventually your game's going to have thousands if not millions of bullets, and then the performance is going to tank. We want some of these pancakes to disappear when they are no longer relevant. So the pancakes that the cat catches and the pancakes that fall behind fall below the line of which we can catch them, we want those pancakes to get removed from the game. So the retain mute is helping us do that. Then this line of code down here, we're adding the velocity to the pancake's y position, displacing the pancakes in the same way that we are displacing the cat, so to say. And then right here for collision, again, these comments are really good here. So this comment is saying that we are checking for collision with the cat. So breaking down the code, this is defining the pancake center. So the same way we define the cat center, we're defining the pancake center, which is the pancake's x plus its radius, and the pancake's y plus its radius, which is the same thing we do up here. And then we are calculating the distance between the cat and the pancake. And this is the math part of the code, and then this down here is kind of like the retain mute. But let's jump into this. So we have, and it says dx and dy. I'm just going to call it distance x and distance y. So we're saying the distance x is going to be equal to the cat center minus the pancake center, and the distance y is going to be equal to the cat center minus the pancake center. So the reason why you have these zeros and ones right here is because we have kind of two different values in pancake and cat. So the cat center has an x value first and then a y value second. Same with pancake. It has a as an x value first and a y value second. So our first value, at least in Rust, our index always starts at 0, which technically 0 is 1. And I can use gamepad to explain that a little bit easier. We call it gamepad 0, but it's really player 1 in this instance, or gamepad 1. And that is because if I had a gamepad 1, it would be player 2 or gamepad 2. So essentially the index in Turbo or in Rust specifically starts at 0. So we're saying the first values of cat center and pancake center are going to be subtracted from one another, and that will give us our distance x. And then we are saying the distance y is going to do the same thing but for those y values, which is the secondary values. So this value right here and this value right here. And then we're going to do some further math. Heck yeah. So we're going to let the distance equal distance x times distance x plus distance y times distance y. And then we're going to do the square root of that. Now, this looks kind of familiar. This is the Pythagorean theorem. So I totally didn't just go and Google what the Pythagorean theorem was. Instead, I totally plugged in my laptop because it was going to die. C equals the square root of a squared plus b squared. So that's why we have the square root value, and our a squared is our x, and our b squared is our y. So y times y, x times x, it's going to equal the square root. So we're calculating the distance of these circles because pancakes are circles and the cat is a circle. So that is a big part of how we are checking the collision code. And then we have two more bits of code here. We have the radius sum is going to equal the cat's radius plus the pancake radius, and we have the radius difference, which is going to take the cat's radius and subtract it by the pancake's radius. And we're saying that this is an absolute value, if you're curious what ABS means. So here is the little kind of like the final check. So we've done all that math before, and now we have this. This is the important line of code. This is checking that they are not too far apart. So for example, when my cat is over here and it misses the pancake, it is too far apart from the pancakes. To move on from this, we now have the score being manipulated to add 1, and then a last munch at being assigned, and then we have some else if and else statements. Remember when I said retain mute is going to return a true or a false value? So that is the instance here. So if the cat catches it, it's false. So when it is false, it removes the pancake from the game. When the cat fails to catch it, it becomes true. Or sorry, when the cat hasn't caught it, it is true. So basically, if that pancake exists within that 144 canvas, then we're going to keep it in the game. We want it in the game. The cat could catch it, right? But when it dips below that 144 canvas, it becomes false, removing it from the game. So all these pancakes that are flying around, when they get past the cat, they enter a state where they get removed from the game. So that is how the whole breakdown of this code is working. So now we pretty much have a game here, but we have no way to keep track of score, and the black background is kind of harsh in the vibes. So let's add in a background, and let's add in our score, and then let's make some alterations to the code here to where we can, you know, like, let's add our own kind of spin to Pancake Cat here. So let us go back over into our code, and we will grab the draw background code. So we'll go down here below Pancake Cat, and we will draw the background. And then we will grab, the only other code here to grab would be the speech bubble code. So I'll grab that as well. And then there's a hidden line of code that's not mentioned here that we'll need to add in. So the speech bubble code, I will add it in below the background code. So I am going to save this. I'm going to see if anything errors out, and it does look like something errored out. Well, it technically didn't error out. The reason why this happened, and I kind of wanted to show this, is I've added in my background after drawing the cat. So let's take this and let's add it before we draw Munch Cat and save it. And now we can see everything. So this clear right here is going to kind of paint the canvas a certain color, which in this instance it is the blue. And then we are doing some math here to print the heart, which are the little hearts. Now this code is supposed to move the sprites, and they're supposed to kind of scroll, but it's not. And the reason why it's not is we're actually missing a line of code from Pancake Cat. So that line of code, and I'm just going to add it right above the state.save here, is state.frame plus equals 1, and then semicolon. So if I save that, we now have the hearts scrolling as they're supposed to. So that line of code is never really mentioned, but it is important because right here we have the frame equaling the state frame as an I32 divided by 2. And it's updating 60 times a second. So basically we're doing 30 frames a second. If I were to do 10 here, then it's gonna scroll so much faster. So I'll get rid of that just to make it a little bit easier to view. But you can see that that is what is manipulating the speed of the scroll. Columns and rows right here. Again, if Turbo starts at 0, so that 0 is now 1, then we have 8 columns and we have 5 rows. So I'm going to do this so we can take a look at it real quick. And cool, it paused at the perfect place. We have 1, 2, 3, 4, 5, 6, 7, 8, and then we have 1, 2, 3, 4. The reason why you don't see the 5th row here is because it is kind of off screen. So the scroll kind of completes itself in a way here to where it looks seamless. So if I add this like so, you can kind of see it there for a second that there is 5 rows sometimes. And I can't really pause it in a way where you can see it, but if you look kind of in this corner, whenever you see these corner ones here, they are 5 of them. So 1, 2, 3, 4, 5. Sorry if that's a little hard to see, but we do have 5 rows and we do have 8 columns. And then we are telling where the X and Y positions are of these columns and rows. So, and they are spaced out by 32 bits. And then we are saying that their position is going to update based off of this frame value. So the X plus the frame value, and then it is divided by the width of the screen. So a lot of our math and numbers here is the 256 value of X minus 32, and then the Y value again, 144, our canvas size, plus 16. You can mess with these values if you're confused as to why they were chosen. With Turbo's quick updating, you can change these values and see what kind of damage you can do. You can do your own little experimenting to see. And then the sprite down here is telling it to print that heart at the X position equal to the X position, the Y position equal to the Y position. So all of those ones. So ultimately, we have the background being drawn. We're giving it a light blue background and drawing a darker blue heart on top of it, which the heart is an actual sprite. We have the Munch Cat being drawn. We have our pancakes being drawn. And then we now have down here a munch animation. I wonder if he's caught a pancake. Yeah, so we now have a little munch text box that appears. Is just a rectangle being drawn, a circle being drawn, a rectangle being drawn, a circle being drawn, and then the text munch being placed inside of that kind of all those shapes that are being drawn and then given a certain color. Now we are missing drawing of our score. Yeah, we can't see our score. So let's add that in. The final little bit of code to draw here is the score. So we go over into this, and I'll just draw it right below the munch animation. I'll save it. And now we have a score. If I were to Command R and reset the game, and our score would go back to 0 because that's where it starts at, and I could start going up. There is two things I want to do to this game to make it a little bit more fun, and these are my own alterations to the code. And I want to give Pancake Cat a sprint, and I want to add a little timer in so that way we can make it a little bit more of like, well, I caught this many pancakes in a minute, or how good can you do? Because right now the game kind of goes on indefinitely. You can just catch pancakes forever. So if you really wanted to, you could pull this up with some friends, and we could see like how many pancakes can you catch in a minute, and then we can kind of go off of that. So let's start with the timer. So I've already messed around with this code a little bit, and the timer is a pretty easy thing to add in. So I'm just going to go down to where we're displaying the score text, and I'm going to go a line beneath it here, and I'm going to add in another text line here. So it's almost identical to the way that the score is being displayed, but I've added in a new variable, so state.time. So time doesn't exist yet up here. So we just have score. So I need to add in this time variable. So I'm going to add in time, and I'm going to set it as a F32, and I'm going to comment that, or I'm going to add a comma there, and then I'm going to do the same down here. I'm going to add in time, and it needs to start at 0 for this to work. So I now have the time. I now have the time, which is a float 32, and then down here I have the initial value of that time in a comma. And then if I go down here, we can see that we're adding in the text, and it is going to display time, and instead of it just displaying it, I have it truncated to like the second decimal value, so the hundredths value, and then that is going to display state.time. And since I don't want it to display right on top of where score exists, I want it to display a little bit further out, so 100x, the y can stay the same, and then I have the same color and the same font size. So let's save this and see if I return any errors or if there is any issues, which it doesn't. So I do have my time being displayed up there. So that's awesome, but it's not moving. So for the same reason of our frames right here moving, we don't have something telling the time variable to move it all. So I'm going to add in a state.time, and I'm going to add 0.016. And the reason why I'm going to do that is because if Turbo updates 60 times a second, I can take 1 and I can divide it by 60, and that value is going to be what I need to update the time by, like add the time. So this adds to itself 60 times in 1 second, which if you did that math, it's going to equal 1. So if 1 is equal to the amount of seconds that have passed, then if I save this, it should just display seconds, which it does. 1, 2, etc. You get it. So I've made a timer. There's probably easier ways to make a timer, but a lot of this game code is kind of like mathed out. So using what I've learned from Pancake Cat here with all of the different math values and variables and functions to kind of code the game, I've made a timer in the same kind of way here. So we have a timer now, so let's add that dash in so Pancake Cat can kind of get some hustle on. And I've chosen to do it this way because of, I guess, just better game feel. And we have not returned an error. So essentially, if everything works the way it is, this should be the finished product of our game. So let's break down the code real quick before I mess around with it. I have my same gamepad, so that gamepad 0. If they click start, or if they press start and they're pressing left or right at the same time, because these two line of codes are the same, then depending on if it's left or right, we will kind of up that speed from -2 to -5, or +2 to +5, and I believe this is just adding on to this value, so ultimately it gets to 7, and that's okay too. It doesn't matter ultimately too much. The feel is what matters more here. So let's see if that works out. If I click left and right, and I also click start, which start is mapped to space on Turbo, then yeah, it looks like he can sprint. And I could have made this to where if I like just pressed it, so basically it worked like this, then I could have the code working like that with a just pressed instead. So I could do start just pressed. But ultimately I don't want to do that because I like the feel of this sprint, so he can kind of keep that quick speed, because it's not so easy to catch these pancakes with the heightened speed because he moves like so fast. So there's going to be times where you want to move like a little bit slower to maybe pinpoint that pancake capture, but you do want to have some speed. So having a little bit more control over it and letting go of it when you want to have like some speed is, I kind of like it better this way. So yes, he could infinitely sprint, which personally I don't see as an issue with this, the way this dash works. I like the way this feels personally, and honestly I kind of get lost in it now that I have a little dash. I feel like I can catch a lot of these pancakes, where before without the dash I'm just too slow to get to a lot of these pancakes, and that's kind of sad. So with the dash I can cover the full distance of this canvas and get to these pancakes correctly. So, well, with that being said, we have Pancake Cat where we need it to be. I'll do a restart. The timer's working, the dash is working, the score is working, his munch is working, the animation is working, the inputs are working, the pancakes are being generated. We've coded Pancake Cat to completion. We've added our own additions to it. We made a game pretty quickly. I do hope that this video helped you take your first steps into using Turbo. Make sure you like the video, comment any fun game ideas or anything like that, and join our Discord so you can get some help in case you have any questions about just what's going on in any line of code that you're working on or any project that you're working on. But my name's Chris. Thanks for watching, and have a great day, guys. Turbo!